Welcome to Motorola's RF design and management software product demonstration. Our suite of design, measurement, and management software includes Enterprise Planner, LAN Planner, Site Scanner, and Mesh Planner. This software is a key component of Motorola's wireless network design process, which helps organizations design a wide variety of multi-band indoor and outdoor wireless networks, including Wi-Fi, 3G, CDMA, GSM, IDEN, Mesh, and even user-defined frequencies. Motorola's wireless network design process consists of 4 key phases: requirements gathering, design, deployment, and verification. Companies that use this approach reduce the amount of time and expense involved in network design, decrease the unknowns in the deployment process, and rapidly resolve any post-deployment challenges. The resulting wireless networks provide superior coverage, capacity, and overall quality of service for some of the most demanding applications, even in complex RF environments. With Motorola's RF design and management software, you produce wireless networks with better performance by design. Motorola LAN Planner software enables network planning teams to rapidly and accurately design robust indoor Wi-Fi networks. Unlike traditional site survey-based methods of network deployment, which require costly and time-consuming on-site work, designers can use LAN Planner to plan the Wi-Fi network on their PC, then validate the deployment and network performance with site surveys using Motorola Site Scanner software. Using LAN Planner helps to reduce labor and planning costs and enables quicker implementation of a high-performance network that considers the types of applications in use, such as wireless voice over IP or asset tracking. LAN Planner also considers the effect of your deployment environment, for example, metal walls, pallet racks, or medical equipment. Gathering information about the number of users planned for the network and the types of building materials in the facility will be an important part of the requirements gathering phase of the design process. Let's take a look at how you can best use this information to put the software into action. What you can see now is a completely modeled facility within the LAN Planner suite. If we tilt this in 3D and zoom in and I hover over a wall, you can see that everything has a height and a material type. There are over 40 different types of material that you can select from within LAN Planner, each with different frequencies and different RF properties. It's important to note that the user can also add, remove, or edit any of these values. I'll now put the building into a top-down view. Sometimes floor plans have not been updated in a long time and you may need to delete walls. To do that, simply select the walls and press the delete key. You'll see that they're removed from the drawing. It may also be necessary to change partition material or the height. To do that, simply select Change Partition Type from the Format Building menu, and then choose what type of material. In this case, perhaps 5-foot-tall cubicle walls. Then we simply use the mouse to select which partitions we want to change, and press the Enter key. When we do that, you'll notice that the partitions drop in height to our 5-foot specification, and they also change color to reflect cubicle material. Now let's go back to a top-down view of the building here. If you have a building that has multiple floors, we can simply use the Show Floors function, show all of them at the same time, and then tilt the drawing in 3D. This 3D nature of the building is very important, as the LAN Planner tool allows you to visualize propagation between floors, so access point coverage and interference can be analyzed appropriately. Here you can see the building as we tilt it in 3D, and obviously all the wings line up. This is a very important step in the formatting process. Now we'll go back to a single floor view, and we'll tilt it in top down. Next, let's take a look at designing a network. You can use the Quick Start AP Placement function to choose an access point, then select the parameters such as placement based on 802.11b, no more than 3,000 APs in a design, and then we simply tell the software about where the users are and what they'll be doing. Here you can see we have 50 users defined in the blue region throughout the building, which are simply surfing the web, and a region of 5 users who are downloading a file. Now we can add an additional region for voice over IP users. Here we'll select how many clients, in this case, let's say 15, and then we'll choose the application type. This is where you can select from a number of applications, and we'll choose voice over IP. Next, we click Draw to identify where inside the facility these 15 users are located. By drawing out this polygon and clicking OK, you'll see that that area now lights up in the yellow color and defines 15 voice over IP users. Next, we'll define the exclusion regions, areas where we don't want equipment to be placed. You'll notice we highlight things like stairwells, elevator shafts, and bathroom stalls. Once I select Done, the software will create a network design plan that considers the building materials, the number of anticipated users, and their application requirements. In addition, the software will assign channels to the access points and reduce their power to minimize interference. Now let's take a look at the network utilization. Network utilization is a measure of how loaded down the access points are based upon the user loads that we've defined for the software. When I click Next, the software will calculate a grid. The grid will display by color how loaded down each one of the APs are. You can see in the legend to the right that the blue indicates a very light level of utilization. The red indicates a very heavy level of utilization. We can tilt the drawing in 3D and zoom in a bit, and in this case you can see that none of the access points meet the 100% utilization mark, which would be an indication that we may have a network problem. I'm now going to clear off this simulation, and we can run another grid, this time showing received signal power, general coverage inside the floor plan. The grid is calculated once again, and another map will be placed on top. This time you can see the legend update and how all of the colors correspond to the given RSSI ranges. You can even use the mouse to hover over a point within the drawing, and you'll see a tooltip pop up to show the exact power at that particular point. Next, let's clear off the simulation for power. Here I'm going to switch to the floor below, and we'll choose to run another simulation, again for signal power, but this time on the floor below. This will show us how much signal, if any, leaks through the floor onto floor 3. And you'll see we do have quite a bit of coverage, but a lot more blue, indicating areas of very weak signal power. Sometimes it may be necessary to move equipment due to mounting location or wiring restrictions. Here I'll show you a real-time network simulation that allows us to pick up an access point and move it in real time. We'll look at the negative 75 dBm signal boundary. I use the mouse to select an access point, and I can begin dragging and moving it around inside the facility. You see the coverage contour update and fluctuate in real time to show you the coverage boundaries of that access point. Once we've selected a good spot, we can drop it, and that area will be shaded in. I can continue doing this with multiple access points. Notice I'm moving the APs away from the VoIP region. Next, we can go through and rerun our network utilization as an example. I choose network utilization from the grid menu and click Next. Here, we'll now see the same utilization map, but it will look much different than before. Because I've moved the access points further away from the VoIP regions, you now see an area shaded in red, indicating 100% utilization. This means that this area, this access point, is a very high-risk AP. If all of the users sign on to use the equipment, then we'll overload this access point's bandwidth. To solve our utilization problem that we've created, we can again use the Quick Start AP placement algorithm. This time, we leave all the user regions the same. We can leave our exclusion regions the same, and now you'll see that additional access points have been added to solve our utilization problem. Now that additional APs have been added, let's revisit the network utilization. This time, when the map is recalculated and put on, we'll see that there are no red regions because we've solved that utilization problem by the addition of 2 access points. Here, we can see that nothing is above 80%. Again, tilting in 3D gives us a slightly better picture of the facility, and we see that we no longer have a utilization problem. With LAN Planner reports, installation teams have a quick reference to all of your design specifications. It's also a great customer deliverable. Here you can see the design summary, which shows the number of floors and the number of APs located on each one. The AP listing table shows us the information for all access points, including height and mounting information, channel, and power. Here the floor plan indicates the placement of each access point. Very handy for the installers as well. As we scroll down, we can look at each one of our user regions as well, where we defined users and what types of applications. Finally, we have coverage maps that installers can use to validate that the deployed network matches the original design specifications. Thank you for viewing our RF design and management software demonstration. For more information about this or other Motorola products, please contact us using the information provided. With Motorola's RF design and management software, you produce wireless networks with better performance by design.